So we've run across recurrence relations already, and like I said, those are basically recursive definitions. And what we have here is that in a recurrence relation, a sub n depends on previous values in the sequence. So it could depend on a sub n minus 1, or it could depend on a sub n minus 1 and a sub n minus 2, or it could depend on n sub n minus 4, or whatever, right? It just depends on some previous values in the sequence, okay? Now, we often talk about solving a recurrence relation. And by solving a recurrence relation, what we mean is that we want to provide some kind of a formula for a sub n that does not depend on previous values, okay? That's a closed form solution or a non-recursive definition, okay? So that's what we're trying to find. Here's an example. A1 is equal to 2, a sub n is equal to 3, 3 times a sub n minus 1, okay? And we can actually solve that. And that's a sub n is equal to 2 times 3 to the n minus 1. This is, in fact, a geometric sequence, okay? Which is nice, okay? Although, by the way, I should caution you that not all sequences are either arithmetic or geometric. In fact, most sequences are neither. But these are the ones that are nice and they're easy to solve, okay? Okay, so we can prove that. Okay, and here is here's the start. So we're giving the kind of a recurrence relation right here, and we want to show that this is the closed form. The way that we prove these things is using induction. Okay, so that's why induction is so important. Okay, so here's our base case. Our base case is n is equal to 1. So we have a1 is equal to 2. That's from this definition, okay? A1 is equal to 2. And then we prove the formula. This is 2 times 3 to the n minus 1, right? This comes from here. And we see that this is in fact equal to 2, so yes, that is correct, right? So the base case is done. Usually the base cases are easy for this kind of theorem because we just check, right? You know, we plug in the formula and go, yep, it's true. Okay. Now, let's look at a sub n plus 1. A sub n plus 1 is 3 times a sub n. That comes from this definition, right? Okay, so that's really the recurrence relation, right? And, oh, a sub n, well, I know what a sub n is. That's 2 times 3 to the n minus 1. This is the induction hypothesis, okay? And notice how I always ask you to let me know what the induction hypothesis is, okay? Well, usually when we get here, the rest of it is just algebra. So 3 times 2 to the n minus 1, that's just 2 times 3 to the n, okay? And, oh, I recognize that that's really 2 times 3 to the n plus 1 minus 1. And now what I have is that a sub n plus 1 is equal to 2 times 3 to the n plus 1 minus 1, which is exactly what we were trying to prove right here, okay? So, yes, proof is done. Right? So that's the way that we'll prove those. Notice that you're supposed to know this, okay? This is by magic, okay? Or by luck, or by observation, or something like that. But we think that's the answer, and now we try to prove that that's the answer. This is the proof, right? That's usually a lot easier than actually coming up with a solution in the first place.